Welcome to our tour of the MotorDoc Empower version 1.1 motor current signature analyzer. So this is a basically single-phase current signature analyzer that is capable of looking at your complete machine, your driven equipment, and one of the phases of harmonic current, which can be used not just for electric machines, but to investigate other things like grounds and neutrals. It's also the first of its type that will look at the earlier stages of what's called supraharmonics out to 22 kilohertz. So it will do an analysis of harmonic conditions from 2 to 22 kilohertz, which is similar to what we have to do on the grid level work, which is 2 to 150 kilohertz. However, in this case, we are focused on inverter applications, single-phase systems in a plant, and so on. So a lot of conditions that you couldn't see before. It also allows us to do further analysis of special items that will go out to 22 kilohertz. Key features of the Empower system is that it takes data at 44.1 kilohertz, and that results in a Nyquist of 22 kilohertz. We display on most of the analysis out to 5 kilohertz, and we also will allow the 22 kilohertz in our new feature, as well as all the harmonics and everything else, which we present as both harmonic orders but also in dB. So let's go ahead and take a quick look at the system. We do leave, which we had released with version 1.0, we do leave the background where you can watch, what we used for troubleshooting, but during the development, but basically so you can watch the system operate. There's also going to be some more information back there if you wish to go and take a look at it. Everything else is built in. So I'll reference you to the new analysis for the demo on data collection. We're going to open analysis when we look at existing equipment. On here, open motor allows us to open existing data before we do data collection. New analysis will also ask for that data, but if we want to update or anything else, bearing data is a new feature. About just basically displays an about screen, which provides information, including contact information for support. And then exit, of course, takes us out of the system. You'll notice a lot of gray space here. That's going to all fill up really fast. So the analysis on this screen, line frequency, RMS current, peak current, those are not editable. Motor speed is. So if we are analyzing a machine that we know the motor speed outright, we can put that in, or we can, when we do the auto analyze, allow it to choose our speed for us. Now it's more than 95% accurate. Now this is strictly for induction machines, although some of our users of version 1.0 have used it on synchronous machines. We still allow for that, but if it falls above the slip, it will say something about synchronous machines. Estimated watt loss, this will also populate. This will include a spectra where it estimates the kilowatts or watts depending on the size of the machine. Additional data will do an energy analysis. It will produce each and every item. We're going to show that in a minute. This is on hold, so this one doesn't do anything, but analyze will allow us to do the calculations. Motor nameplate is where we enter in our motor nameplate, including bearings and everything else, which is why we have the bearing data. For rotor bars and stator slots, right now we have a Excel spreadsheet available for our users. Because of the feature that we're building next, we can't build this in along with the bearing data yet. But this will be built in on version 2.0, which will be out by March. which is also going to include, by the way, wind turbine analysis. And when we pull that information up, we will have some of the stator slots and rotor slots for defig, as well as rotor bars and stator slots for some induction machines for wind. These don't do anything right now. That's going to be changed in version 2. Coupling, etc. This allows us to put in belt information, gearbox information. We're going out to 3 stages. These are where you would put the number of teeth for the pinion, etc., etc. And then bearings, we include a space for a thrust bearing. Anywhere where you have not included information, it will skip that. So if you only have 1 bearing worth of information, I'll take care of that. It adjusts, all the multipliers are adjusted by speed based upon the ratios. That includes in the belted application. So if I select belt and I select fan, it's going to take my running speed, it's going to take a look at the ratios in the belt, and it's going to apply that speed into pump or fan. So then in here, I'm able to put in number of blades. I can put in bearing sizes. If I don't have bearings, I can put in the number of blades and get my data. For whatever I'm going to do, say if I have a belted application and a fan, I do have to check both of those because that is what it's looking for. So if it sees this, it'll adjust the speed on this. If you're not careful, you might pop an error. It'll be a pop-up box saying, you messed up. When you're done, you can select this. The other new feature we added, we actually put it in version 1.0b because one of our heavy users wanted the ability to test neutral and ground harmonics with the system. Current harmonics, of course. We added this in. We'll show you a demonstration of that. And then finally, settings. And this is also an area where we have renewed stuff. So this will be the sensitivity of your device. And you'll save that so that anytime you start up, it's conveniently there. So when you first start the software, after you license it, then it will ask for that sensitivity, which is on a sticker right on your data collection device. If I have multiple of them, and somebody goes out in the field and they collect data on motor ABC and they're using a certain sensitivity, when you open the data, it will put that sensitivity in here so that all of your data is worked back to the device that it came from. This right now, these 3 here are not being used. We are focused on this one in the middle, which takes 120 seconds. Actually, that gives me 0.009, but just rounded up to 0.01. And this one here, that would take 15 minutes. So we've left that out for the time being. We may add it in the future. It's not a significant coding issue. We just reduce confusion. And the idea is that somebody can pick this thing up, learn how to use it in about 15 or 20 minutes and collect data. The system does all of the analytics. All of those rules are built in. Millivolt per amp, that's for the data collection device. CT ratio, which will default to 1, but if I'm taking off of say the back of a Multilan or SEL or any of those relay devices or whatever, any display, analog display, and I've got it coming off a CT, I put in the CT ratio, and this will be to 1. So if I've got 200 to 5, that would, of course, be, 40. So anyways, I'd put that in there, and then, never do math when you're in the middle of presenting. These are the defaults right now. So emission base is 0.498, which is the U.S. average. Reduction, so if I find a defect and I fix it, that reduction is a different value. And right now the present U.S. is 0.699. You can change these whenever you want. The important thing we added to version 1.1 is this. Because we found, it's been 2 months since we released this system. Noisy systems may raise the noise floor. We also found that with the empath systems. In the empath systems, we manage that as well. But in this one, we initially had not. So before we'd say, okay, you have to manually adjust your alarm settings or change the results. This will automatically adjust for specific conditions. It will change the alarm settings. You won't see it here, but it will do that in the background so that you reduce or virtually eliminate false positives. Basically, if this system is telling me I have a defect, electrical or mechanical, in the machine I'm testing, the coupling, or the driven equipment, it's going to be very correct. So that's kind of it. So let's do a quick demonstration. We've done the quick overview. That's what's there is to it. There's a lot of stuff in the background. Well over 10,000 lines of code. A lot of hard work by the MotorDoc AI team. So let's see what they did. First, let's take a look at this motor bearing database. Now, this is stored as a SQL, an encrypted SQL database. When I open that up by pressing the button, there it is. And I can select a bearing manufacturer. So let's say, let's select SKF, because why not? I select SKF, and I can either search through all of them, or I can say it's a 6310, and when I get that, I can select, so it'll find any of them with 6310. So let's pick the 2Z. There we go. It's got that one, or if I selected this one, because I have multiple databases, there are over 83,000 bearings in this database from multiple sources that I've collected since 1999. So in any case, that's all there. So let's exit out of here. Let's go ahead and add now, and we are going to open some data. So let's open some existing data. And this is the small motor we have here. Let's grab something from in the field. Let's grab a motor and fan. So let's come here to, I think I had these. There's an exhaust fan. Let's take a look at this one, 'cause you can do some inrush analysis with this. That'll be a later discussion. That will also be a full feature when we get around to version 2. So the first thing I did is I selected the WAV file. Now this saves the findings as sound files. Okay, the next thing is you'll notice that says .json. So it saves these as JSON files. For those who are involved in the internet, you know what the JSON files are. So anyways, that's basically a text file that holds a certain format with the data that we had shown there. So it's going to populate all this stuff. And you can see what's going on in the background. You can see millivolt per amp 10, CT ratio this, the calculated current and everything is already there. What it's doing right now, it's creating all of the interactive images that we're going to be able to work with. Basically plots. Now the software itself, when it's installed, is a single executable. It'll install wherever. Oh, and this has multiple frequencies here. So it picked one of the frequencies there. This last one, it says it's 47.99 or 48 hertz. It is accurate out to the 2 digits. So I have the information here. It's displaying my estimated watts. It's not displaying anything here because I haven't analyzed anything yet. Here's the machine itself here. Now to do the in-depth analysis, I still have to select kilowatts. So it's that. And coupling and driven, here's the fan. Okay, so we'll end up looking at that as well. and then any of the settings that we had set up for that machine are here. Okay, so millivolt per amp at 10, yeah, all that stuff is set up. So once I've done that, I can simply click on Auto Analyze. Now you'll watch the screen. Used to take about 90 seconds for it to hunt down the speed. It is now instantaneous. That was our big leap. So it takes about 30 seconds to 40 seconds, depending on how busy your laptop or computer is. But let's go ahead and we'll click Auto Analyze. It's telling me still that I need to wait 2 minutes. There's a pop-up that's on my other screen. But here you go. It's selecting all the stuff. It's setting basically everything. You can see I have a raised noise floor, so it's countering that. And it's doing all the analysis that I need. And all the changes are present in this pull-down list. So if you need to go back and say, what on earth did it do? You can go back and do that. And you can see all that mess in the background. That's basically the analysis being performed. And it's setting all the spectra, and then it's going to start into the kilowatt spectra, which it did here. And then as soon as it's done, it's going to plot all of that. Right now, all these vertical lines you see here, those are all the line frequencies. So you can see those here as well. Those are orange in this one. Okay, here we go. So it found a DE and ODE bearing defect in the machine, and it will show you where those lines are, so you can go, maybe not, and so on. Another thing we have to be able to take a look at that. Well, let's walk through this. It selected a speed which we know is exactly correct. So 1241.46. Here we have the kilowatt analysis, which you'll notice if you get into it, goes up to 5 kilohertz, which is the equivalent of 300,000 CPM. But if I come in here, these buttons here allow me to zoom in. You'll notice that I have basically what almost amounts to orders. So that's all in there. If I come here to additional data, this will show me the watts lost for each of those conditions. So it said ODE. It looks like the ball, because that's my highest number here. And it looks on the drive end of the other one, it's also the ball, maybe the cage. But when I see a combination of that, and this will be also in version 2, will be some of our additional analytics, it's going to actually tell me, check grease, because if I have a ball or cage issue and I don't have an inner and an outer race issue, these numbers would be much, much higher. Those are in watts. Those would be much, much higher. Well, the other thing I can do when I see this, so there's 742 watts that are here, and a big chunk of that is this pole pass frequency as well. But let me go ahead and click Analyze. And it's basically saying that the motor's overloaded, which we knew, and it gives me the energy in kilowatts, gives me the estimated consumption in kilowatt hours for a year for that machine, and the greenhouse gas emissions for that machine for the year, based upon the other calculation, the 0.498. Then it'll say, okay, here's my opportunity for correcting everything, including harmonics, 6,500, and then that would reduce my emissions. The more I can get that down, the lower this will go, so I can get the emissions down. So I'm looking at, about 4.5 tons of CO2 from what I've seen here. And then the energy opportunity is about $650 to correct that. Now, that does not include certain other things. So, for instance, the 120% of load had to do with a mistake made here, and you can see 11 and 12. The actual original one was like 14 and 10. That caused a bit of a problem. These are for your notes. It will save and it will reopen. So let's say we have this belted application. I don't have the driven equipment in there, But let's say I have the belted application. I click on this. It's going to do a quick analysis. I can see that in action here. I did this because you'll notice it's not all instantaneous. We wanted to have that. It's going to set a shiv problem and a belt defect. So if I go back here now, it's added the belt slip, the shiv problem, and belt defect. All are now included. The other thing I can do here, let's go ahead and we're going to turn this off. Oh, and by the way, what it also did was pop this graph up at the same time. Now, what's kind of cool about the Empower system is wherever I am, so it's going to show me where it thought it was. So that's there. I can save that figure and put it in whatever report, or I can do certain other things with it. So let's go ahead and we're going to close out of this. So if I am wondering if I have any harmonic issues, and this is output of a drive, so let's select harmonics, and we're going to click Analyze Driven. Of course, it'll pop up on the other page. And here's my spectral analysis. This is out to 22 kilohertz, and this is my firing frequency, about 4 kilohertz. You can see 8, 12, 16, and 20, and it'll continue on out. Those are harmonics. Now, when I switch over, the values are going to be very low, but they're very high frequency. And it's that very high frequency that involves the skin effect and a bunch of other things that occur with those high frequencies that are going to affect my equipment. So I can use this then to say, hey, I got stuff going on way out here. In this case, we know that they have a continuous problem with bearings here. So this high frequency is causing part of their problem. So if I click down here in harmonic analysis, this is first going to pop up my current waveform. And I can come in here and look at whatever detail I wish. See there? Let's go in even closer for fun. Let's kind of center this a bit. And then we're going to go in and we're going to look at one waveform. There we go. So those are all the frequencies that are sitting on that main frequency that we are going to analyze. So let's go ahead and click Open Harmonic. Now, one of the cool things I was just mentioning about, and you can see here, it's going to show the frequencies and what the values are in actual current. In the meantime, it's popped up this screen and this screen. Now, this screen here is for my harmonics. And as a matter of fact, let's see what this is. Wow, look at that. 84th order harmonic over 1% in current. So that means that my total harmonic distortion up to the 50th, which is covered in 519, is 0.38. My full range is 1.52. The supraharmonics, meaning everything over that 50th harmonic, is ridiculously high. So the reason they're having some problems in this system has to do with that. This does display even harmonics as well, and just like everything else, my navigation allows me to move around and see whatever I wish. Okay, so, and if I drag that down, of course, it's going to, so I can see down, I can see up, I can see whatever I want. Whatever's on display here and everything else, if I come in here and I say, hello, this is harmonics. When I'm finished with that, I save as PDF. That's going to save a report for me. And that report is going to be harmonics. It won't display right after. I'll have to go and open it up if I want to see it. But there it is. It has saved it. So that's it. And then here, all of this mess, that would be saved when I click here. And whatever I put in the nameplate, it's going to do that here. So let's select Test and Save. We're going to replace it. Okay, so the other thing I could do if I really wanted to is I could start another instance and another instance and another instance of the same software as long as my RAM allows it. And I can take a look at multiple machines, do some comparisons, especially if I have multiple screens. I've already been doing that for an energy study we're doing, and so on and on and on. I can do all of that. Let's go ahead and exit out of here. This will disappear as well. And we will pause for just a second. Okay, so here is this test report, and it has the basic data in there, what the equipment name is, who the manufacturer is, whatever you filled in. And let's see if we can get this to do what it's supposed to do. And then I scroll down, it's going to show me the results, what it actually found as far as everything else. And this display will show based on whatever I'd selected. Then it's going to show all those watts there, whatever was on the screen, estimated load, everything else, and that's the report. Any comments I'd made would also go on there. So that's the first part, and then finally that harmonics report. Okay, that whatever I typed in, hello, this is harmonics, and then there's the first graph. That's the way I'd left the current waveform, and that's where we were looking on here, and that's it. So very straightforward, an inexpensive way to plow into current or electrical signature analysis. We've been able to show people with zero experience how to apply this in 15 or 20 minutes, and they've done a great job. As a matter of fact, in one case, a young lady, an accountant at a repair shop, went out with us in the field to see the device in action. We got her up and running in just a few minutes, and then she was showing everybody else how to use it after she tested a few machines. So that's it. If you have any questions, reach out to us. Right now, it's on special until the 31st of December in 2024. After that, it's going to be full price. Yes, we are still looking for additional distributors and reps. There are some exclusive territories or the ability to get an exclusive territory available, which is all merit-based. And that is it. So thank you very much for your time. Hope you enjoyed this tour. And if you have any questions, like I said, reach out. You'll notice in this case, it does certain things. In the other case, we have the empath system. The empath system requires a little more thought in order to analyze. It does a lot of different things, including a lot more work on power quality, identification of loose connections, and then more energy-related work and a little more accuracy when it comes to that. So we do offer for Empower users the ability to buy up to an empath. You get to keep your Empower, but you get a discount on a new empath, and vice versa. So if you're a MotorDoc empath user, meaning you purchased it through us or one of our reps, then you can purchase an empath an Empower at 50% off. So with that, have a great day and Happy New Year.